Hey everybody, this is Mr. Aynesworth, and we are going to get into your activity here and correct your works. A lot of students requested help on this, so here we go. Go ahead and get a pencil and a red pen handy here. Let's go ahead and go through it. Make your corrections in red, and then I'm going to go through it step by step. So if I go a little bit too fast, remember there's a video. Pause, play, rewind, and here we go. All right, so first thing what we need to do is set up a little bit of things here, because what I'm going to do is I'm going to step things out, but I'm also going to show my thinking over here. So let's write down side work here. All right, and let's do a little side work. So when you get experience, you can do it all in your head, but let's do a little side work. Whenever you multiply binomials, okay, there are two things you can do. You can use FOIL, because that always works for binomials, which is first, outer, inner, last, which is basically an acronym for what's called distributive property, okay? Distributive property, so something that you've been using ever since you were little. So this is going to be equal to first times first. We got to take 3 root 6 times 2 root 5. So first step is 3 root 6 times 2 root 5, okay? Now you multiply like terms. And the order in which you multiply doesn't matter. The grouping doesn't matter in multiplying. All right, so when you multiply like terms, I'm talking about 3 and 2. And 3 times 2 is obviously 6. All right, and then you multiply the other like terms like root 6 and root 5. What does that give you? Well, root 30. Okay, so there we go. So you multiply like terms. So you multiply what are called the coefficients of the radicals, 3 and 2. 3 times 2 is 6. You multiply the radicals. Okay, rad 6 times rad 5 is rad 30. There you go, that's how it's done. So you get 6 rad 30. And notice that I'm showing my thinking off to the right. That's step 1. Okay, step 2. Okay, outer product. First, outer, inner, last. 3 root 6 times negative 3 root 6. So 3 root 6 times negative 3 root 6. You multiply like terms. Okay, so 3 times negative 3 is negative 9. That should be obvious. And then root 6 times root 6, well, that is root 36. Okay, a root times a root is a root. That's what they say. Now root 36 is 6, so negative 9 times 6, and that equals negative 54. Okay, so we got negative 54 there. Okay, step 3. First, outer, inner, last. So the inner product here. Okay, so 5 root 5 times 2 root 5. So 5 root 5 times 2 root 5. So we get, again, what do you get? Well, you multiply like terms. 5 times 2 is typically 10, especially on Wednesday. Today's Wednesday. Yeah, there you go. So that's 10. And then a root times a root is just another root. So root 5 times root 5 gives you root 25. All right? A root times a root is a root. So you get 10 times 5, because root 25 is 5. And that should give you 50. So I'm going to add 50 here. So notice that I'm just calculating off to the side. When you get experience, you don't show the side work, but this is an instructional video because people are having a hard time with dealing with all the radicals here. So I'm stepping it out in detail. All right, and the last product here is 5 root 5 times negative 3 root 6. 5 root 5 times negative 3 rad 6. Notice the use of parentheses because I got negative numbers. All right, so we got to make sure that looks like multiplication. 5 times negative 3 is negative 15. Times root 5 times root 6 is root 30. You don't need the parentheses there really. So you get negative 15 root 30. Again, a root times a root is a root. Root 5 times root 6 is root 30. Think simple. So minus 15 root 30. Collect like terms right here. So in the middle, negative 54 and 50 is negative 4. Okay, so you can write that first if you want, or you can write a second, doesn't matter. Or you can just bring it down right here. And then it doesn't really matter whether you write it first or second, it doesn't matter. And then 6 rad 30 minus 15 rad 30. Well, 6 minus 15 is negative 9. So we get a negative 9 root 30. You combine like terms. So you get negative 9 root 30 minus 4. Okay, and these are unlike terms, so you can't combine. Okay, you're dealing with a radical 30 here, and a negative 4 was an integer. So you can't combine roots with non-roots, so they're unlike terms. Okay, which means you cannot simplify, or you cannot combine. You cannot combine, cannot simplify, however you want to say it. Okay, all right. And there we go. And that's how you do it. Okay, just simple multiplication right there, guys. All right, now, the next few have hints. You can either take the hint or you can leave it. All right, you don't have to factor out a common factor of 6. Some of you guys like distributing through, but distributing through, you got to be careful because it causes bigger numbers. I mean, root 6 times root 18, if you can do that in your head and then simplify in your head, great. However, that's not the easiest way to do it. So I suggest you simplify the roots first. So either factor out the root 6 or simplify and factor out the root 6 first versus multiplying through. There's 2 ways to do it. Okay, but I'm going to write down simplify roots first. Okay, to factor out the root 6. All right, you'll see what I'm talking about. So here we go. We're going to get 4 rad 6 in the beginning. Rad 6, the factors of 6 are 2 and 3, so splitting the root up into root 3 and root 2, it really doesn't help you much. Okay, so 3 root 18. So here we go. This is where we simplify. So here we go. We're taking a look at the first one here. Now 3 root 18 is the same thing as 3 times root 6 times root 3. Why? Well, I mean, think about what I said earlier. A root times a root is a root. Root 6 times root 3 is root 18. So all I did was factor first, okay? And that's easy to do. Multiplying 6 and 18 together, distributing through first, that's the harder way to do it, believe it or not. Okay, so minus 2, just bring down the minus 2 here. Root 24 is root 6 times root 4. Or root 4 times root 6. I'm going to write the root 4 first. Root 4 times root 6, and then bring down the root 6. Okay. So once again, I just factored first. Oh, simplify roots first? I meant factor roots first. Sorry, so change that. Factor. Okay? I factored the 18, I factored the 24. So factor roots first. Sorry about that. Now, the reason why we do that is because, look at this right here. They have a root 6 in common. And guess what? That's called a common factor. Okay, that's why the hint was given. Okay, now you could factor that out. So watch this. I have a 4 root 6 up in front. Okay, obviously. When you factor out the root 6, I'm going to put that in red. So times root 6. There's your common factor. There's your root. There's your root 6 is in common. And then you have 3 root 3 right here. So 3 root 3. And then you'll have the 2 root 4, all right, because you're going to factor out that root 6. So minus 2 root 4, which I'll simplify here in a minute, plus 1, because when you factor out the root 6 from the root 6, well, you have 1 remaining there, because root 6 times 1 gives you root 6. Remember, if you distribute back through, you should get the previous step. That's how you check your factoring. Whenever you factor something out, just distribute it back through, and you'll check your factoring. So let's finish. We got 4 times 6 here. And then we have 3 root 3 minus 2 times 2. Obviously, root 4 is 2. And then plus 1. So simplifying here, we've got, what do we have? So we have 24, obviously. 4 times 6 is 24. Times the quantity 3 root 3 minus 4 plus 1. Negative 4 plus 1 is a negative 3. So we have 24 times 3 root 3 minus 3 as our end result. Okay, and if you distribute it through, if you did, okay, if you distribute like this all the way through, 3 times 24 is 72, so you have 72 rad 3, and then 24 times this 3 here, the second one, gives you another 72. And there, my friends, is the end expression here. If you factored out the 3 instead of distributing through the 24, your other way you can represent your answer is this right here. Okay, it'd be 72 times rad 3 minus 1. That's the same thing. All right, and because of this guy right here, the root 3, okay, root 3 is irrational, so this whole expression is irrational. Okay, so this entire thing is irrational. Okay? Like on the previous one, I forgot to say whether it was rational or not. Root 30 is irrational. So this whole thing is irrational. Whenever you can't simplify a root in your ending expression, it's going to be irrational. If it's not, if it's rational, it can always be expressed in an integer divided by an integer. Remember that. That's rational form. You guys know that from earlier. In fact, let me just remind you. Rational form. This is from section 2. Is equal to a over b, where you have an integer divided by another integer. You guys already know this. All right, where the denominator is not 0. And because of root 30 and root 3 and root 2 and all those things, they can't be expressed as a ratio of two integers, then obviously it's not rational. Okay? It's a non-terminating and non-repeating decimal. That's another way to think about it too. You enter in root 3 on a calculator, you're going to non-repeating, non-terminating decimal. Okay, moving on. Same thing on this one here. Now you could distribute through. You can multiply root 12 times root 3 to get root 36. You could do that. And root 12 times root 48. But not too many people know what root 12 times root 48 is. You can't, it's hard to do that in your head, so I don't suggest you do that. Okay, so I suggest you factor the roots first. Okay, so factor roots first. That's the, and in order to do this right here, in order to factor out the root 3, you got to factor out the roots. Okay, so here we go. So we're going to get 2 rad 12 times what? Well, with 3 root 3, you can't simplify that. Root 48, you can. Okay, since you want to factor out a root 30. Root 3, you 48 is divisible by 3 16 times. So this is root 3 times root 16. And this is plus, not minus, plus 2. And then root 27 is root 3 times root 9, right? Because guess what? 3 times 9 is 27. All right, so all I did was I took root 48 and I re-expressed it. I took root 27 and I re-expressed it. Okay, that's all I did. So I didn't do really anything fancy. Now, I've got 2 root 12 in front. I want to factor out the common factor, and it's right here, like this. I'm going to underline them. Root 3 is involved in all 3 terms, so you factor it out. So I'm going to. So what do we get remaining? Well, you get the other terms remaining. So you get the 3 in front here. Root 3 times 3 is 3 root 3, minus root 3 times root 16 is right above it, okay, root 3 times root 16. And then you take out the root 3 out of the third term, okay, you get 2 root 9. Now you simplify. So here we go. So 2 root 36, 3 times 12 is 36, minus times the quantity, 3 minus 4, because root 16 is 4, plus 2 times root 9, which is 3, and 2 times 3 is 6, so there you go. So simplifying further, you get 2 times 6 times, root 36 is just 6. And from left to right, 3 minus 4 is negative 1, plus 6, 5. Okay? And so, you get 12 times 5 here, which is 60. And that, my friends, is a rational number because, well, 60 divided by 1 is still 60, and you have an integer over an integer. So this has got to be rational. All right, so our end result is rational this time. It's not always rational. If you end up with a square root in your expression, it's going to be irrational. All right. Now let's try the next one here. So you've got, let me see, we got a sum and a difference. Is the difference of squares, just so you know, is a squared minus b squared, and that's equal to a plus b. Let me write a little bit better here. A plus b times a minus b. So the question is this the sum and difference of the same terms? So let's analyze it. Okay, so 3 root 6, 3 root 6, 5 root 5, 5 root 5. Ah, so it is a difference of squares because it's a sum and a difference. So what we need to do, and if you don't believe me here, just switch the order here. Just switch the order here and you'll see it. It's the same idea. So here's A and here's B. Okay, and this is A. Excuse me, that's B. So So that's A and that's B. So A minus B first, and then A plus B or B plus A, it's the same thing. All right, so it's equal to, right, A squared minus B squared. So you got to take the 3 root 6 squared minus the second term, 5 root 5 squared. This is the structure of it, okay? You got to use structure. As I've said in the my previous videos, okay, it's important as a mathematician that you see the structure of it. When the terms are the same and when you're adding and then subtracting, it's called a difference of squares. A plus B times A minus B is always A squared minus B squared, and so all you do is square both and subtract. Okay, look at this. Square both. All right, and since it's minus, you subtract. That's all you do. So that's all you have to do in your mind. So notice I squared both of the terms and I subtract them. Now when you square terms, you square both terms in here. So 3 squared is 9, root 6 squared is 6, 5 squared is 25, root 5 squared is 5. So you get 54 minus 125. Now 50 minus 125 should be, negative 75, but then you got to add 4. Negative 75 plus 4, negative 71. Okay, so when you subtract, you get negative 71, and my friends, that is a rational number. Why? Because you can rewrite it as negative 71 divided by 1 is an integer divided by an integer. And there we go. Okay, now you could have used FOIL here. I mean, if you didn't see the structure, you could have used FOIL instead, okay, or distributive property, and you just multiply it just like I did the previous ones. You can always do that, but if you want to really excel and speed up your arithmetic here, you're going to learn how to see the structure in it. Whoa, hang on. Let's reboot. Okay, sorry about that. And you're going to see the structure in what you do. Okay, that's one of the goals in MRWC, is that you see the structure in the mathematics. Okay, you're just not robotic or procedural all the time. You actually, you see the structure in it. Like this one here. Same thing. You have a sum and difference of the same terms. So here's your first term, that's like your A. Your second term, root 5, is like your B. So really this is A minus B, right, times A plus B, which is equal to A squared minus B squared. So that's why we said the difference of squares. So you square the first term, which is root 12 minus 3. You square the next term, which is root 5, and then you see what you get. Okay, you square both and subtract, like I said on the previous one. Now when you square a binomial, okay, you square multiply double square, which is something I've talked about in my previous lessons. So you square the root 12 to get 12. You multiply negative 3 in root 12 to get negative 3 root 12. This is what you should have in your mind. But then you double it, which means times 2, and you get negative 6 root 12. So minus 6 root 12. And then you square the negative 3 to get 9. Okay, so this right here, when you square the binomial, you get these 3 terms. And then when you square the root 5, well, you just get 5. Okay, and then you continue. All right, 12 plus 9 is 21, minus 5, 16. So 16 minus 6 root 12. So 16 minus 6 times root 4 times root 3. And so you get 16 minus 6 times 2 times root 3. So that gives you 16 minus 12 root 3. And you are done at this point. Okay, and because of this right here, the root 3, this is irrational. And again, anytime you end up with a root, it's going to be irrational. All right, you can't express this as an integer divided by an integer. Not possible. Okay, this is a non-repeating, non-terminating decimal if you check it out on the calculator. So the whole idea is to get used to structure. Like on this next one here, it kind of looks like the previous one, yeah? Okay, so I omitted some of the symbols, but you got to rearrange the terms and use the difference of squares just like the previous one, because it's not the same order. So if you want to put it in the same order, then it might help you see things. So let's work on the first trinomial and put it in the same order as the second one. So let's just go ahead and switch here. switch the order. Easy to do because we're in addition here. So the addition, the order doesn't matter. So I'm going to rewrite it as root 5, okay, and then 3 root 2, and then the root 7, so that you guys see that this is actually the same order of terms, but you're going to see that we have a plus root 7 in the first trinomial and a minus root 7 in the second binomial. So if I group up these two and these two, there's your first term. And then your second term is the root 7 and the negative root 7. So once again, this is a difference of squares. So this is a plus b, and this is a minus b. And there's your structure, and it's always equal to a difference of squares. First term plus second term, first term minus second term. A minus b times a plus b is always a difference of squares. So you square the first term, which is root 5 plus 3 root 2. Got to learn how to square that binomial, minus the root 7 squared. And again, it's always, when you square the binomial, it's always square the first term, multiply double, square the next. So you square the root 5, and then you multiply the terms. Okay, 3 root 2 times root 5 is 3 root 10. This is what you should have in your mind. Then you double it, and you get 6 root 10. So you get 6 root 10 here, and then you square the 3 root 2. So mentally, when you square 3 root 2, you get 9 times 2, or 18. 3 squared is 9, root 2 squared is 2, 9 times 2 is 18. So I get plus 18, and then bring down the 7. Why do I say that? Well, when you square root 7, you get 7. And then you add 5, 18, and minus 7. You add the like terms. 5 plus 18 is 23, minus 7, 16, and then bring over the 6 rad 10. And that is irrational again. Why? Because the square root. All right? Anytime you have a square root, you're going to end up with an irrational number. Okie dokie. Here we go. Now on the next one here, we got to figure out what the exponent is. And the hint is to use the difference of squares. Why? Because we have a minus b times a plus b again, and that's always equal to a squared minus b squared. There's the structure. Okay, so let's do that. Let's do a little side work. So let's take root 7 minus root 2 times root 7, root 7 plus root 2. And that's going to be equal to root 7 squared minus root 2 squared, which is just 7 minus 2, or 5. So really what this is saying is to say, hey, take root 3 and raise it to the 5th power. Again, do a little side work, as I always do in my lessons, okay? If you can't do it all in your head, don't worry about it. Just do some side work. Okay, now, what is this? Well, let's see. Root 3 times root 3 times root 3 times root 3 5 times. Okay, I get 3 here, and I can't simplify that root 3. And so I get 9 root 3 total. Once again, step it out. Okay, step it out, do a little side work, use structure, piece of cake. All right. And again, if I'm going a little bit too fast, you guys, this is a video. Pause, play, rewind, okay? In fact, I want to write it down, okay? It's a video. Pause, play, rewind if you have to. You know, listen to it a few times, okay? I use instructional videos from looking at other people too. And when I watch other people do things, you know, mathematical things or, you know, things in other subjects, sometimes I have to rewind too because I didn't get the first time. So, you know, use your videos effectively. All right, here we go. Now, there's different ways of doing this, but you want to factor the roots first to simplify. So factors of root 63. So this is equal to 4 times root 9 times root 7. Why? Well, root 63 is root 9 times root 7. 9 times 7 is 63. Plus 5 root 7. Minus 8 times root 7 times root 4. Or I probably should write them backwards. Write the root 4 first. Why? Because you're going to simplify it. So what I just did was I I just simplified the roots. Root 28 is the same thing as root 4 times root 7. Root 63 is the same as root 9 times root 7. Now you simplify. So 4 times 3 times rad 7 plus another 5 rad 7 minus 8 times 2 times rad 7. That gives me 12 rad 7 plus 5 root 7 minus 16 rad 7. Well, all you have to do is add the coefficients. 12 and 5 is 17 minus 16. Well, that's 1, right? So 1 rad 7. So all you get is root 7. You can put 1 root 7, but that's the same thing as root 7. And my friends, that's an irrational number. All right, because like I keep saying, the square root of a non-square is always irrational. Okie dokie. Let's continue. We got just a few more to do. All right, again, simplify. So this is equal to root 4, all right, times root 11. 4 times 11 is 44. Plus 5 times, Now, if this is hard, you take 176 off to the side and factor it. So divided by 2 because it's even. Let me see. Half of that is, 88? That's 160, yeah. Divided by 2, 44. Divided by 2, 22. Divided by 2, 11. Okay, so I see a square here and here. And the biggest square that I see is here. So 16 times 11 is 176. Okay. Now, if you didn't know that, you can just factor it. So let's factor that. So root 16 times root 11 minus 3 times root 9 times root 5. Once again, I'm factoring the roots. Root 45 is the same as root 9 times root 5. And then I got to factor the 99. Well, what's that? Well, let's see. You got plus. Hang on for a second. I need to do something. Bring that up here a little bit. Okay. Need more room. So plus 2 times root 9 times root 11. So all I did there was just factor. Right, 99 is 9 times 11. And then root 20 is root 4 times root 5. Okay, so there we go. All right, all color-coded for you. So you get 2 rad 11 plus 5 times 4 times rad 11 minus 3 times 3 times root 5 plus 2 times 3 times root 11 minus 2 times rad 5. So what do you get? You get 2 rad 11 plus 20 rad 11 minus 9 rad 5 plus 6 root 11 minus 2 rad 5. So let's add up all the root 11s. 2 and 20 is 22 plus 6 more is 28 rad 11. So we get 28 rad 11. And then minus 9 root 5 minus 2 root 5 is minus 11 root 5. So we got a minus 11 root 5. And that, my friends, is irrational. Okay, anytime you're involving a root, that's an irrational term. There you go. All right, we're rocking. So let's see here. Dun, 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 dun. Let's keep it rocking. Now remember, this is a video, so if you need to go back and check it out. Okay, so let's rationalize the denominator. So notice the denominator involves a root. And rationalizing, you want an integer down below. It says rationalize the denominator, so make it an integer. Well, to do that requires the conjugate. So let's multiply it by 7 plus rad 2 over itself in the form of 1. Put parentheses around all your binomials, make it look good. This is the process of using the conjugate to rationalize either the denominator or numerator, whatever you're told to do. So, and the conjugate is when you change it from a minus to a plus or a plus to a minus. It's that simple. Okay, so here we go. So we get 5 times 7 plus root 2 up top Down below is the difference of squares. So remember, a minus b times a plus b, well, that's the difference of squares, a squared minus b squared. So I got to square the 7, okay, to get 49, and I got to square the root 2 to get 2, and what do I get? 5 times 7 plus rad 2 up top, oops, divided by 49 minus 2, which is obviously 45, not 47, sorry. Come on, Aynesworth. So 47. There we go. And if you want to distribute through the 5, it looked like this, 35 minus 5 rad 2 divided by 47, which is another irrational number. All right, but notice the denominator now is an integer. Okay, that's what it means to rationalize it. You want the denominator to be an integer. If it says rationalize the top, the numerator, then you want the integer, the numerator to be an integer. If you want to rationalize the denominator, then you want the denominator to be an integer. Okay, and that's how it's done. So let's try it on this one. Let's multiply it by 8 plus root 3 divided by 8 plus root 3. We call this a form of 1. All right, it's called a form of 1. Why? Because anything divided by itself is 1. All right, and then you go for it. You multiply. So let's distribute through here. We're going to get 56 plus 7 root 3. And again, this is equal to a plus b times a minus b. Excuse me, yeah, which is the difference of squares. So you're going to square the 8 to get 64. You're going to square the root 3 to get 3. So the end result is 56 plus the 7 rad 3, all divided by 64 minus 3, which is obviously 61. And that is how it's done. All right. Now, when you rationalize the numerator, same idea, but now you want an integer up top because the numerator is the top number, right? So you want to multiply it by another form of 1. So here we go. So 7 plus rad 2 over itself. All right. Put parentheses around everything. All right. So when you multiply the numerator again, a plus b times a minus b is always equal to a squared minus b squared. We call that a difference of squares. And notice that we're using it a lot. All right, because you're supposed to be doing things quickly. You're supposed to see structure and everything. So get used to that. So 7 squared is 49. Root 2 squared is 2. On the bottom, you get, if you distribute through the 3, you get 21 plus 3 root 2. So the end result is 47 divided by 21 plus 3 root 2, irrational number. And then the last one here, you multiply it by 2 plus root 5. Again, the conjugate, just change it from a minus to a plus. All right, divided by the same number because you want a form of 1. All right, because you're not changing the value when you multiply something by 1, and that's why this thing is legal. That's why this process is legal. All right, because in multiplying something by 1 only changes its looks. It doesn't change the value. You can check what I'm saying with a calculator if you want. Okay, so here you're going to, again, this is a minus b times a plus b. There's your structure. Oops, sorry. There you go. And it's always equal to a squared minus b squared. So you square both and subtract. So you square the 2 to get 4. You square the root 5 to get 5. That's easy. Is that easy, guys? And then you distribute through here. 3 root 2 times 2 is 6 rad 2. 3 root 2 times root 5 is 3 root 10. So end result, negative 1 divided by 6 rad 2 plus 3 rad 10. And that's just another irrational number. But notice that we rationalize the numerator. It's an integer. Okay? So there you go. And that's how it is. That's activity 3B4. Modified, that is, by me. I'm Mr. Aynesworth. I know it's not the exact original activity in MRWC, but I thought it was a little bit too long, so I modified it, made it student-friendly, and went through everything in detail. So, again, this is a video. Go back and use it to your advantage. And remember, this is your instructor here, Mr. Aynesworth. This is year 2020. We're in the COVID crazy pandemic time here. And that's why I'm producing so many videos because you guys need it. And you guys requested it because you needed some extra help because this stuff is not easy. It requires you guys to be very good at some very important but basic skills called factoring, which is not always easy. All right, so do your best. Now practice, and I'll see you in my next lesson. I'll see you then. Bye-bye.